Welcome back to section 9.2, part 2. We'll be doing confidence interval estimates for two independent samples. So for the confidence interval, we'll be using the TI-84, but we can, I just want to bring your attention to the margin of error. We can find the margin of error by taking whatever upper limit we get and subtracting the difference between the two sample means. So for the confidence interval estimate, just a reminder, what we're looking for is if it does or does not include 0. If it does not include 0, then we can assume that they have different values. If it does include 0, we can assume that the means are the same, or that they could be, that there's a however percentage confidence that they could be the same. And just a reminder of how to pick your confidence level based on your significance level and the tail number of the test. So we'll do two examples. So using the previous data, which I have here below, construct a 95% confidence interval estimate of the difference between the mean course evaluation score for female professors and the mean course evaluation score for male professors, and then identify the margin of error. So for this one here, we are talking about, and let me go back to my notes here, that the claim was that they are equal. Okay, so our null was that they are equal, the means are equal, and the alternative was that they are not equal. So we're going to go to the calculator, and we're going to go to stat, tests, and to sample t interval, because now we're talking about intervals, t interval. And we'll have our females as our first one again. So the X bar there is 3.867, or just about, 0.563, 12, 3.993, and 0.396. And let's see, it looks like that's 15. They're talking about a 95% confidence level. Data is not pooled. Calculate. All right, so here we get our confidence interval, and that's the only thing we want to look at, that negative 0.5245, or excuse me, negative 0.5278. So negative 0.5278 is less than the difference between the two means. Less than, let's pull this back up, 2758. This is the confidence interval right there. So let's examine it for a second. Does it include 0? And the answer is yes, because we go from negative to positive. So it does include 0. So it suggests that there's not a significant difference between the scores, because the scores could have a difference of 0. So there's not a significant difference because the interval contains 0. It wants us to identify the margin of error. We can find the margin of error by taking the upper limit and subtracting the difference between the two means. So our upper limit is 0.2758, and we can actually take our difference means right from the data. So when we calculate that difference here, so 0.2758 minus, use that parenthesis, 3.867 minus 3.993, we get a margin error of about 0.4018. So we're 95% confident that the limits, and we just rounded here, between those two do contain the difference between the two population means, and because those limits contain the value of 0, the interval suggests that there is not a significant difference between them, because if the difference could be 0, then there's not a significant difference. We'll do one more example. So we've done this one before. This is the blue and the red, and now we're going to construct a confidence interval. Now they didn't tell us the confidence level, so we have to take a look here. We just need to remember that our null was that they're equal, and our blue was 1 and red was 2. And our alternative was the claim that the blue enhances performance there. So this is a right-tailed test. So we have a significance level of 0.01. It is a right-tailed test or a one-tailed test. And so that means that we will double our significance level. And so we're going to be using a 98% confidence level. And that comes from this table here. So again, we have a one-tailed test. We're looking at 0.01. Okay. So we're doing a 98% confidence level. And let's go to the calculator. So same thing, stat, test, 2 samples, t interval, and our first x bar is 3.97, 0.63, 36, x bar 2, 3.39, 0.97, and 35. Our confidence level is 0.98. No, and calculate. And we get about 0.114. It's less than the difference between the two means. And 1.05. Well, we did 3 digits. 1.046. So we're 98% confident that the difference between the two population means is between 0.114 and 1.046. That does not include 0. So that supports the claim that there is a difference between the two means. So blue enhances performance, just like we found with the hypothesis test. So now with the 2 examples you did previously, go ahead and do the confidence interval. I give you the significance level. Go back to that table to make sure you're using the correct confidence level. And press play when you're ready to see the solution. And there you go. Neither of these include the value of 0. So now what happens when you know sigma? Just assume that you don't know sigma and then do everything the same that we did before. So when we know sigma, we're not going to actually do anything different. We'll assume we don't know it and do all the practices that we just did in 9.2. So that concludes section 9.2.